So we have f of x equals 5x to the 7th over 14 minus 6x to the 4th plus 3x minus 5. Find the derivative. Right? So this is straight. We did a bunch of these polynomials. I hope everybody got this right. You bring the 7 down and you get 5x to the 6th over 2 minus 24x cubed plus 3. Okay? 2 points, pretty much 2 or 0. The TAs can decide if they want to give you partial credit or not. Second one, I wrote it wrong in my answer key, so there you go. Second was a power rule. We had f of x equals x cubed, I'm sorry, it was a product rule, x cubed plus 2 square of x minus 4x. If you wanted, you could distribute that first, but it's kind of annoying with the square root, so I wouldn't bother. I would just do the product rule. You take the first equation, first function, multiply by the second, derivative of the second, plus reverse. And you're done. Okay. Not so hard. Third one, they got sort of progressively harder. This one you can do with the quotient rule. So f prime of x, bottom function times derivative of the top minus top function times derivative of the bottom over the bottom squared. So far so good? Okay. We had D. Yeah, I'll do D over here. Oh, so let's see, that one was worth 4 points. So 2 points and 4 points and 4 points. This one was worth 5 points. Okay, so we have to use the quotient rule. So take the bottom function times the derivative of the top, which is 3x squared plus 6x plus 1 squared times 2x plus 6 minus x squared plus 6x plus 1 cubed times the derivative of the bottom, which is 1/2 2x minus 5 minus 1/2 times 2 all over the bottom squared. You could write the square root squared. You know, there's a variety of ways to write these, okay? You did not have to simplify, which you knew. That was worth 5 points. That was the messiest one, but I'm just seeing if you could take derivatives. If you could take derivatives, you get lots of points in this part of the test. And then the last one, we had x cubed plus 1 over x cubed cubed. Derivative is 3 x cubed plus 1 over x cubed squared times 3x squared. And the derivative of this is x to the minus 3. So that's minus 3x to the minus 4. Some of you treated this as a quotient. I did the quotient rule. You don't need to do quotient rule for 1 over something. Okay, that's just to a negative power. How do we feel so far? So if you're pretty good on these, then that's 20 points already out of the exam. And you're flying high and you say, okay, I'm going to rock this. And then you get to the other questions. And then you don't feel so good, but that's okay. I'm very sympathetic. Many of you, I see how hard you're trying, and you show up and you do your stuff. You're doing okay. Can't guarantee you're all getting A's, but you're doing fine. All right. Question 2 is a tangent line question. It's funny, you guys say to the professors, when are we going to actually use this stuff? All right. No, we lost one. And I said, well, since you're not allowed to use calculators and computers in a class like this, I can't really show you a lot of the applications that you'd use this because the numbers are dumb if you can't use a calculator. You know, you have to do tiny numbers and simple numbers and small examples. I really wish that in 122 you could use a computer, but you can't. Oh well. But for those of you who are going to take me for Business 215, we use a computer almost every class. So if you're taking me in the spring, make sure you have a laptop that runs Excel. Download the Stony Brook version of Office 360. Use that Excel, not whatever you have right now on your computer. All right, number 2. Find the equation line tangent to y equals 3x minus 5 over 3x squared minus 10 at x equals 2. Equation of the tangent line. So first, let's find the y value at 2. Y at 2 is 3 times 2 minus 5 over 3 times 2 squared minus 10 equals 1 over 2. That was worth a couple points. Just getting the y coordinates. Now I have to find the derivative. Derivative, we do low d high minus high d low over low squared. Okay. Now we have to evaluate it at x equals 2, so we can get the slope. That's going to equal 3 times 4 is 12 minus 10 is 2 times 3 minus 6 minus 5 is 1 times 12 over 12 minus 10, which is 2 squared, which comes out negative 3/2. Nice easy number. So you get y minus 1/2 negative 3/2 x minus 2. And of course, leave it in that form. You don't have to simplify. So far, so good? Okay, another 10 points. You're not passing, but you're getting closer. All right, third one. Okay, we have y is 12 plus 9x minus 3x squared minus x cubed. One intervals is y increasing or decreasing. If you want to find where it's increasing or decreasing, you need to take derivative, set it equal to 0. You get 9 minus 6x minus 3x squared. You want to set that equal to 0. So many people have trouble with the quadratic when the x squared is not in the front. So factor out a negative 3. You get x squared plus 2x minus 3 equals 0. X equals negative 3 or positive 1. So you got about 3 points just for getting to there. 3 out of 6. All right, then let's sign test this. If you pick a value less than negative 3, this comes out negative. Then if you pick a value between negative 3 and 1, this comes out positive and negative. So it is increasing. when x is between 1 and -3, it's decreasing for x is less than -3 or x is greater than 1. You could use interval notation. You weren't required to. Any questions so far? No? Yes?
Is writing it like that the same thing?
Well, no, it's not domain. I don't know what you mean. Right. Yeah, domain is what you're allowed to plug in. Right? So x can be anything in a polynomial. Right? This is where the graph is going up and where the graph is going down, remember, right? So, but if you mean is it the same as interval notation, you mean this? You're not required to do that, but you certainly can. And the other one would be, okay? Is that what you meant? Yeah, okay. So no, you don't have to use interval notation. It's nice to know, but since you guys aren't planning to generally to go on in math after this course, interval notation, it's really for mathematicians and physicists and like, it's just a way of compressing your notation. All right, so what are the coordinates of any maximums and minimums? Maximum, minimum. Well, let's see. This is a minimum. When x equals -3, y equals, you just plug -3 into the equation. 12 plus 9 times -3 minus 3 times -3 squared minus -3 cubed. I am sensitive to the fact that many of you are helpless without a calculator. I am well aware of that. Okay? You have paper, do the best you can. It doesn't cost you a lot of points either way. So that's a minimum, because it's going down and then up. So the minimum is at -3, -15. And when x equals 1, y equals 12 plus 9 minus 3 minus 3, which is 17. Minus 3 minus 1, sorry. There we go. So there's a maximum at 1 comma 17. And then if you want to graph this, well, we know it has a minimum here at -3, -15. A max at 117, so probably something like that. And by the way, that's the y-intercept is 12. You don't need to label it, but you could. Something like that is perfect. And you get 5 points for that. You get 3 points just for getting the shape right. You feeling good so far? Some of us are feeling better than others. Are you allowed to GPNC this course? No? If you are, some of you should have. But of course, you're the ones who showed up. The 40 survivors. I don't think you can. I don't think business students can GPNC this course. All right. We have y equals 3x to the 4th minus 54x squared plus 18. Where is it increasing or decreasing? So same thing. dy dx, 12x cubed minus 108x. I tried to give you nice numbers. Factor out 12, you get x squared minus 9. So that's 12x, x minus 3, x plus 3. And that means you do the sign test, minus 3, 0, 3. And if you test it, you get that. Okay? So this is increasing on -3, 0, or 3 to infinity, or in non-interval notation, x between -3 and 0, x greater than 3. And it's decreasing -infinity to -3, 0, 3, or x is less than -3, x is between 0 and 3. So same as before, now we're going to find the maximum and the minimum of this moment. Okay, what are the coordinates to the maximum? So let's see. So we're going to have this curve is going down, up, down, up. So the minimum's at -3 and +3. So y at -3 is 3 times -3 to the 4th minus 54 times -3 squared plus 18. That is 3 times 81 minus 54 times 9 plus 18, which I recognize was a bit of a chore, but if you stuck at it, you get -225. And at +3, well, -3 to the 4th and -3 squared are the same as +3 to the 4th and +3 squared. Now, hopefully you noticed that that's also -225. So you have minima at -3, -225, +3, -225. And then the maximum is easy. That's 0, 18. So far, so good? You guys don't look happy. Okay. Where is it, concave up or concave down? So if one was concave up or concave down, we take a second derivative. So the second derivative is 36x squared minus 108 equals 0. You get x squared equals 3. I told you, it's very hard to make them both come out as nice numbers. You end up with these, you have to do really big numbers sometimes. So you do the number line. And you get plus minus plus. So it's concave up, concave down, concave up. Concave up on -infinity, -square root of 3, and 3 to infinity, square root of 3 to infinity. Also known as x is less than -square root of 3, or x is greater than +square root of 3, and it's concave down in the middle. Or makes me tired. Okay, What are the coordinates of points of inflection? Well, we have one at square root of 3 and one at negative square root of 3. They're going to be the same because of the squaring. So y at the square root of 3 is 36 times the square root of 3. I'm sorry, it's 3 times, my bad. Square root of 3 to the 4th. Minus 54 times square root of 3 squared plus 18. What is the square root of 3 to the 4th? Well, the square root of 3 squared is 3. Then you just square it again and you get 9. So this is 3 times 9 minus 54 times 3 plus 18, which is negative 117. Same for the negative square root of 3. So they're square root of 3, comma, negative square root of 117, and negative square root of 3, comma, negative square root of 117. And then if you want to graph this, we've done a bunch of these. It's one of those W-shaped graphs, okay? And those are the points that we found, our maximum, our minimum, our points of inflection. Okay. I don't think I'm sick. I think I'm allergic to this room. The chalk dust is amazing. Okay, we're almost done. Okay. Some exponential log stuff. You knew this was coming. Oh, God, well, I don't know I wrote that. Okay. F of x equals e to the x, or x to the 5th plus 1. So the derivative, quotient rule. Bottom function times derivative of the top, which is just e to the x, minus top times the derivative of the bottom over x to the 5th plus 1 squared. Okay? B. F of x equals x squared e to the minus x squared. I think we did this one in class. Or we did x squared e to the positive x squared. I forget. I know we did close. So product rule. First function times the derivative of the second, which is negative 2x e to the minus x squared, because it's e to the minus x squared times the derivative of the power. Plus derivative of x squared, which is 2x e to the minus x squared. Okay. The third one, I forgot to write the f of x in the exam. Nobody caught that. You just put 1 minus x squared on the bottom and minus 2x on top. That's the derivative of the log. Okay. D. We had f of x is x to the 5th natural log of 6x. So f prime is x to the 5th times the derivative of the log of 6x is 6x. Bottom 6 on top, so it's just 1 over x, but you could also write 1 over x. Plus 5 5x to the fourth log 6x. Good, almost done. E. F of x equals e to the x minus e to the minus x over e to the x plus e to the minus x, also known as hyperbolic tangent or tanh. Any of you ever want to be engineers, you learn hyperbolic functions. Those are the trig functions of imaginary numbers. Complex numbers, kind of. It's complex. So I have faith that none of you care. But the derivative as well. I think we need a little more room for the derivative for this one too. Yeah. Bottom times the derivative of the top. So that's just e to the x, and the minus minus becomes plus e to the minus x. Minus top function times the derivative of the bottom function, which is e to the x minus e to the minus x, all over e to the x plus e to the minus x squared. Okay? Last one, equation of a tangent line. Okay, y equals x squared e 4 minus x. And we're going to find that at x equals 4. Okay, first, need a y coordinate. So y at 4 is 16e to the 0. E to the 0 is 1, so it's just 16. And we need a derivative. dy dx is x squared. The derivative of e to the 4 minus x is minus e to the 4 minus x. This is e to the 4 minus x times the derivative of 4 minus x. Plus 2x e to the 4 minus x. Now we do this at x equals 4. We evaluate this. And we get 16 times e to the 0, or negative e to the 0, sorry, plus 8 e to the 0. E to the 0 is 1, so this is negative 16 plus 8 equals negative 8. And that means that the equation of tangent line is y minus 16 is negative 8, x minus 4. You're sitting there, you're wondering, did I put this? I don't remember. Maybe. It's all a blur. Monday night was a long time ago. Right afterwards, it was right before Halloween, so tequila, Monday night at the bench, wings night, Monday night football, etc. All right, Friday we start new stuff. Everybody have a nice day. You don't have to do anything else today.